Hello. Just wanted to do my fractions video for the week. Again, I sent an email. I apologize for this being a late week. It's been an extremely busy week with my other job and trying to get caught up, and then a late service last night at World Harvest. So apologies. And this week will be extended. So I know it's Resurrection Week. It's Easter week, and people have family and things they do. So don't feel rushed. Don't feel, you know, tied up in, where you got to set time aside to make sure you get all this done. I'm going to keep the week extended, so it's not going to be due. I'll extend it at least till Thursday. And even if that's a problem, write me, send me something, and we can work from there. No problem at all. So I'm not going to penalize you guys because I, get tied up and get dragged down. So. Anyway, fractions in the book, page 53, I think it goes up to like 72. I said it's a pretty lengthy section. And just, I want to go over the simple. There's a couple videos I found online. I couldn't find one that had all the material I wanted. So there might be two other ones that are going to be where you can actually see the work. I tried again the other day in the room, and still, like I said, everything was recorded backwards. Unless I have somebody with my phone to do it, which, I don't have a lot of friends just sitting around with an hour to nothing to do. So, but I could find somebody. But anyway, I'm just going to emphasize some key things on here. Those other videos will give you a visual demonstration mainly of the setup and things like that. So combining these two should be a good benefit for you. Starting off, just like I said in the book, reviewing fraction. Fraction, of course, it's part of something. It's something broken up into different sections. It's a part of a whole group. Remember, almost all fractions are a part smaller than one. Obviously, we'll get in situations where you'll see an improper fraction and mixed numbers that are greater, but most fractions that you see are less than one. They're a part of a whole unit broken down. And just so we can go forward, the numerator is the top number, the denominator is the bottom number. So going forward, we use those two terms a lot, so just be comfortable with which is which. And then we see the terminology on page 52 or 53. I'm sorry. Proper fraction. That just simply means the numerator, the top number, is smaller than the bottom number of the denominator. Okay, and those are the most frequent type of fractions that we're used to. Where it says name for one, I've never really used that term. I usually just say it simply that any fraction where the numerator and denominator are the same is equal to 1. That's a great tool to know going forward. 4 over 4 is equal to 1. 5,000 over 5,000 is equal to 1. 25,000 over 25,000 is equal to 1. Doesn't matter how big or how small those numbers are. If they're the same top and bottom, it's equal to 1. It's just like picturing a pie cut into 8 pieces. It's one whole pie. And if you take all 8 pieces individually and take them all out of the pie, you've eaten 8 out of 8 pieces, one whole pie. Hopefully you can see that kind of similarity going forward. It's a very, like I said, good tool to know, especially when we get into borrowing. You'll see exactly what I mean. Improper fraction is exactly opposite of the proper. That just simply means the numerator now is bigger than the denominator. So if the number on top is bigger than the bottom, we have ourselves an improper fraction. We'll get into later how to change it into a mixed number. And then the last thing is a mixed number, which is a proper fraction, but also has a whole number in the front. And you'll see a couple examples there: 2 1/3, 10 1/4. It's just simply adding a whole number in front of a proper fraction. Again, at the bottom, you'll see that all they're doing is just simply taking some simple illustrations and turning them into fractions. So number one, there's 100 cents in a dollar. What fraction is 17 cents? 17 over 100. Remember, in a fraction, the bottom number is like the whole, how many whole units there are and whatever we're talking about. Like I said, with the pie or pizza cut into 8 pieces, the bottom number is, there's 8 pieces it's cut into. The top number then would be the number that you're kind of dealing with in the problem. If I take 3 pieces of pizza and eat them, I could ask, well, how many pieces of pizza have been eaten? Well, the 8's not going to change. It's always going to be 8 pieces of pizza. I ate 3, so the 3 would be on top. I could also change the question and say, how many pieces of pizza are left? Well, if I've eaten 3, that means 5 are left. So then the fraction would still have the 8 as a denominator, but the 5 would be on top now because we're talking about how many pieces are left. So the numerator is the ones that it's going to change based on the question. The denominator and fractions are, that you'll see, are always going to stay the same. And we'll get into that as we're going through here. Comparing fractions, this is the one thing where I like to tell a couple illustrations because a lot of videos and stuff I see don't use this, and I've always found it to be helpful with people in the times I've taught in the past. If the numerators are the same, if we're talking about like 1 over 7 and 1 over 8, and which one is bigger, okay? You got to kind of, with fractions, kind of loose your mind a little bit as far as your, like, so you're thinking 8's bigger than 7, so therefore 1/8 would be bigger than 1/7. But in this case, that's not the situation. Think of a 1 on top as the number, that's your share of something, and the bottom number being how many people you have to split it with. So if your family received an inheritance of $5 million, would you rather only have 3 siblings or 7 siblings or 8 siblings, or 7 people to split it with, or 8? Obviously 7, because that means more for you. So if the numerators are the same, if you have 1 over whatever, or 2 is whatever, 4 whatever, think of that top number as that being your share, and the bottom number, how many people you have to split it with. So the smaller the denominator, the bigger the fraction. So it's kind of a little bit reverse thinking. So again, that first example, or first actually practice problem on page 54, 1/3 is bigger than 1/6. People see the 6 bigger than the 3 and think, well, okay, that's bigger. But actually think about it that way. You're getting 1 share, you're splitting with 3 people, or you're splitting it with 6. Splitting with 3 means you're going to get more. So therefore it's the bigger. And they do a great thing there with drawing the picture. As you can see, if you have the same size pizza and you only cut it into 3 pieces, well, then 1 piece is going to be pretty big. If you take that same size pizza and cut it into 6 pieces and only get 1 piece, you're going to get a much smaller piece. So great visual illustration there too, if you see the picture. So some good examples going down through there. Now the exact opposite is true if the bottom number, the denominator, is the same. If the bottom number is the same, that means the number on top is your share. Okay, so I say it's similar thinking, but it's slightly different. So if the bottom numbers, like number 4, are both 10, that means you have, picture, like I said, I always use money because people like to deal with money. Picture a pot split, into 10 bowls of money. The top number, would you rather have 6 of those pots, or would you rather have 9 of those pots? Obviously 9 is worth more than 6. So if the denominators are the same, then you want to use the logic you've grown up with. 9 is bigger than 6, therefore 9/10 is bigger than 6/10. Okay? So bottom number is the same. Think of the top number, that's the amount, that's the share I'm getting. If the top numbers are the same, that's the share I'm getting, and the bottom number is how many people I have to split it with. So similar, but again, hopefully that makes sense what I'm saying. And again, if you need to, if you're a visual learner, same situation like they did with the circles, the pies, draw the circle, cut it into 10 pieces, and think, well, if I take 6 out of one and I take 9 out of another, 9 is going to be a much bigger section than the 6. Okay? And then, as you can see, starting with 5 and then going down through, they start mixing and matching. Sometimes the denominators are different, sometimes the numerators are different. So in those situations, like, what do you do? Well, the easiest thing to do would be find a common denominator. Okay, and as we're going through, as you jump over to 55, you'll see we start doing this. Common denominator just simply means a number that both 2 numbers will go into. So if you have a 3 and a 5 as a common denominator, or what does 5 and 3, not gets into them, but that they go into. So 5 and 3 would be 15. You can always find a common denominator by multiplying the 2 numbers together. Sometimes there's a lot smaller number that you can use though, like 4 and 6. If you had those as 2 denominators and you wanted to find a common denominator, well, you could multiply 4 and 6 and use 24. That would be fine, but it'd be easier to use 12 because 4 and 6 both go into 12 evenly. The smaller number, the easier it is to deal with, the easier the math is in the long run with multiplying and subtracting. It just makes it much more easier for you in the long run. So we'll jump now to 55. It said finding equivalent fractions. Equivalent fractions simply means a situation where the numbers look different, but the value of the numbers are exactly the same. And it's a great, again, circle there. And I usually do this for my classes too. excuse me. Sorry, just checking. My brother texted me. Top. You have the same size rectangle or square. It looks a little more like rectangle to me. In all three pictures, but it's just cut up differently. And the first one is only cut into 3 sections. The second one is cut into 6 sections, and the fourth one's cut into 12 sections. Notice the sections are at the bottom, the denominator, how many sections it's cut into, and the top is how many of them are shaded. And the first one 2, the second one 4, and the third one 8. But if you notice, if you took out the grids inside, the same amount is shaded in each of the 3 rectangles. Okay, so 2/3, 4, 6, 8, 12 are all the same value. The numbers are just different. And I usually do the same illustration, except I use a circle and I use like a pizza. If I take a nice 16-inch pizza, and start cutting it, if I only cut into 8 pieces, okay, and take 2 out, I've taken 2 pieces out of 8. If I take that same size pizza, but instead of cutting into 8 pieces, I cut it into 16 pieces. Well, now if I take 4 pieces out, it's the exact same value as taking 2 of the 8. Okay, and if you draw that and see that, you'll see that 2 out of 8 and 4 out of 16 are the exact same value. The numbers are just differently, but when they're in fraction form, same value. All right. And the example that you start seeing going down through this page is, so when you start going like 2/3 and you want to make it a equivalent fraction, if you multiply the numerator and the denominator by the exact same number, you get an equivalent fraction. So if you take 2/3 and multiply both of them by 2, top and bottom, 2 times 2 is 4, 3 times 2 is 6, you get 4 6. So therefore 2/3, 4 6, exact same value. If you take 2/3 times 3, numerator and denominator times 3, you get 6/9. So 6/9, 4/6, 2/3, all the exact same value. Okay, so hopefully everyone can see that. It's pretty basic, pretty standard. And then going down through the practice on that page, you're just filling in a lot of the blanks to show that how you're finding equivalent fractions. Practice number 1, fill in the missing numbers. As you can see, it starts with 3/7. You're changing that into 12/28. So to get to 12 for the numerator, you're multiplying 3 times 4. Well, if you multiply the top times 4, you have to multiply the bottom times 4. So that missing block would be a 4 also. 4 times 7 is 28. So 3/7, 12/28, exact same value, just different numbers. Okay, and then the bottom is a lot of the same, except we're going backwards now. So the top part, you're going from a smaller fraction to larger by multiplying. The bottom, you're going from a larger fraction to a smaller one by dividing. Okay, but they still have the exact same value. So if you have, and I will say real quick that this bottom section, reducing, is one of the most key things to remember, because you're always going to reduce fractions. Get used to it, because correct answers will always be in what we call lowest form. By reducing, simplifying, you'll hear both those terms used. And so what that simply means is that you have an answer, like the example there's 12/30. Well, you can break that down because 2 goes into both of those numbers evenly. You're always looking for a common factor, something that will go into both numbers evenly. In this case, it's 2. 2 goes into 12 6 times, 2 goes into 30 15 times. But then if you look there, you can say, ooh, 6/15, that still has another common factor, which is 3. So 3 goes into 6 2 times, 3 goes into 15 5 times. Now if you go back to the start of the problem and say 12/30, you might have seen that 6 will also go into both those evenly. You could have done it in one step, 6 into 12 2 times, 6 into 30 5 times. So the end result being that 12/30 will reduce down to 2/5. Okay, so they have the exact same value, but 2/5 is reduced down to the smallest units that we will deal with. So that's why we reduce, to make everything simple. And the bottom is doing that. So again, just like we did up top, 12/14, if you're simplifying that, 2 goes into both of them. So 12 divided by 2 is 6. The empty block on the bottom would be another 2. If you divide the top by 2, you have to multiply or divide the bottom by 2. 14 divided by 2 would be 7. So 12/14 is reduced down to 6/7. And that would be what you do on that page. Renaming improper fractions. Apologies. When an improper fraction is is an amount that's going to be greater than 1. It's actually going to be worth more than 1. So we change them into mixed numbers or whole numbers depending on their value. And the example there, like I said, the first one is 2 out of 2, in which we learned already on the first page that's equal to 1. Anytime the same number over itself is equal to 1. The second example is 4 over 2. 4 over 2, you have large number on top, it's improper. 2 goes into 4 2 times. Okay, so how we do that, and as you can see, going down and reducing to a mixed number, or renaming to a mixed number, anytime you have the top number bigger than the bottom or the same, you're simply dividing the bottom, the denominator, into the top, the numerator. So as you can see in the bottom, 7 divided by 4. 4 goes into 7 one time. That'd be your whole number, whatever, how many times it goes into. And then the remainder, in this case, is 3. That becomes your new numerator. So, and the denominator never changes. You'll see it all the way through here with, renaming, adding, subtracting. So if you have a 4 down there, it's going to stay a 4. So 7 over 4 is going to change to 1 3/4. Another just key thing to say here is just remember the terminology is when you're reducing, that simply means you're taking a proper fraction and reducing it down to smallest terms. Changing is when you say we're changing a improper fraction to a mixed number or a whole number. So just if you hear me say reducing or why you got something wrong, maybe you didn't reduce, or if you see me say how would you do that, you need to change that number. So reducing and changing, two different things. A lot of times people want to interlock those two, but they're not the same thing. Okay, so just be careful in the terminology. And like I said, the bottom, a lot of practice on that as far as getting used to doing that, changing improper fractions to either whole numbers or mixed numbers. Remember, divide the numerator by the denominator and go from there. Next page, another kind of good thing to learn. That's it's a nice little tool to know, especially if you can get it down to where you don't really need to refer to a book or anything. Is changing a fraction to a decimal and a decimal to a fraction. Kind of interweave the two, because a lot of times what you'll have going forward is problems that involve both. You're going to change one to the other, and it's kind of up to you, whichever way you think is easier. Some people like going one way, some people like going the other way. It's all on your feel and how comfortable you are making that change. And as you can see at the top, just a simple start is 1/2 and 0.5, 0.5 being the exact same value. That's the same value as a fraction and a decimal. Okay. Most people can see that one. It's pretty standard. It's the other ones we start dealing with that it's not quite as simple. But reading down through there, it's hard for me, like I said, to do a visual without writing stuff down. But it's very good to look at the top of that book or top of that page on 57 to just see the difference and the similarities, how to go from one to the other. If you start with a decimal and go to a fraction, I think this is much easier. When you have the decimal, look at your decimal and determine what place value that the number ends in. So there, right there, you have 0.2. Well, that only has one number in the tenths place. So you know that tenth is in your mind, tenth, 10. So when you make your denominator, it's a 10. Tenths, 10 is your denominator. And then just simply take the number, in this case 2, and put it as your numerator. So you have 2 over 10. But as you see, it gets reduced, just like you learned before this. 2 goes into both 2 and 10. 2 goes into 2 one time. 2 goes into 10 5 times. So 2/10 as a decimal is equal to 1/5 as a fraction. So same value. If you say I want 1/5 of something, it'd be the same as saying I want 2/10 of something. And in the bottom, you'll see the example is you start with a fraction of 1/4. And you want to change that to a decimal. In this case, anytime you want to change a fraction to a decimal, divide the bottom into the top. Now normally the first thing that people think if they haven't never done this is I can't divide 4 into 1, which technically is true, but I don't like how the book here doesn't work this out. So when you divide 4 into 1, make your bracket. Remember the 1 goes in the bracket, 4 on the outside. You can't divide 4 into 1, so immediately add the decimal. Do not forget that step. Add the decimal first. So put it straight up on top of the bracket. Then start adding zeros. When you add a 0, you're dividing 4 then into 10. 4 into 10 is twice. 2 times 4 is 8. Remainder of 2. As long as you still have a remainder, you have to keep adding zeros. So add another 0. Now you're dividing 4 into 20, and 4 into 20 goes 5 times with no remainder, so your answer then would be 0.25. So 1/4 and 0.25, again, same exact value, just different ways of looking at it as a fraction or as a decimal, okay? When you do this, you're dividing and changing it into a decimal, you'll find times that maybe it doesn't work out evenly and you're like adding zeros and adding zeros. Eventually, most problems will say round it off after the hundreds place, thousands place. But sometimes you might have to go out 3 places to the thousands to work out evenly. Okay, so as long as you have a remainder, add zeros. But if you've gone 3 or 4 places and it still hasn't worked out evenly, you might want to think about rounding it off at the tenths or the hundreds or thousands place. Okay, and usually the example or the book will say to do that. Another example at the bottom, just to do one of the practice ones. Number 2 at the bottom of 57, 0.45, and it's again we're changing a decimal to a fraction. So 0.45, it's 2 places, therefore it's the hundredths place. So think hundreds, 100. That's your denominator is 100. Then just simply take the number, in which case is 45, make it the numerator, so it's 45 over 100. And in that case, reduce it. 5 goes into both numbers, so 5 into 45, 9 times. 5 into 100, 20 times. 9 over 20 would be your fraction. And again, always remember that the book, you should have the answers in the back. This book should have the answers in the back, so if you get stuck or you want to check your answer, make sure you're right. The other example that to make sure to go over there is number 6. It's a 3.5. Okay, so you have a whole number in front. In that case, don't worry about that whole number really till the end of your answer. Just make sure you focus on the 0.5. 0.5, that's tenths. 10 is your denominator. Put the 5 on top. 5 over 10. That reduces down to 1/2. And just plop the 3 in front. So it's 3 and 1/2 would be the equivalent. So 3 and 1/2, 3.5, same value. Jumping over to 58, this is a cool, very, very cool little chart. I've encouraged people to use it before. Using the divisibility rules. This is an awesome, awesome tool going forward if you could ever really learn this. There are times, a lot of times I've referenced this. Especially if I don't have a calculator handy and I'm trying to simplify something, divide something. Most people know the first one, all even numbers are divisible by 2. Most people know that. But it's really cool if you start learning the rest of them. I don't want to break down all of them because they're pretty self-explanatory. Like to know if a number is divisible by 3. And this is good if you're trying to reduce a large fraction. Like if you have 1,245 over 2,574, can I reduce that fraction? And you're going, you need Christmas, I don't know, But like, how to figure out if 2 numbers are divisible by 3? Well, add the digits. What that simply means is if you have the number 1,245, add those digits 1 plus 2 plus 4 plus 5. Once you get, that number, which in that case is 12, if that number is divisible by 3, then the whole number is divisible by 3. It's a really cool tool. And then if the bottom number, you would have like say 2,574, add those numbers up, which in that case is 18, which is divisible by 3. That whole number is divisible by 3. So 3 would go into both of those numbers, and then divide it and reduce. And so forth down that chart. It's really, really, like I said, it's a cool thing to know. And there's really no other way to do it except to kind of study that chart. So cool stuff. Jumping over to 59, common factors to simplify fractions. And what this is a kind of a step for some people because the reducing doesn't come as easy. Some people it comes no problem. They can look at a fraction and say, okay, 4 goes in both of those, I can reduce it. Other people it's more of a struggle. They kind of don't see it. This page is mostly for people like that to say like, okay, how can I reduce something? What numbers am I looking for? How do I find them? I just don't see it. Well, the good example is going down through is go down about halfway to the simplify 8 over 12 and write down the factors for each number. Now a factor just simply means any number that divides into that number evenly. So for 8, you'd have 1, 2, 4, and 8. that all go into 8 evenly. Then do the same thing for 12, which you have 1, 2, 3, 4, 6, and 12, all go into 12 evenly. Remember, 1 and the number are always 2 factors, and then match up into the other ones. And then what you look for is any numbers that appear in both sets. So in this case, and you want the highest one of that group. In this case, it's 4. 1, 2, and 4 all appear in both sets, but 4 is the highest of the 3 numbers. So use the highest number you can. And then simply say, okay, I'm using 4 as the greatest common factor. 4 goes into 8 twice, 4 goes into 12 3 times. Therefore, you've reduced 8 twelfths down to 2/3, okay? So what they want you to do then is start finding factors for all those numbers. Factors of 18, always start with the 1 in the number itself, so you'd start with 1 and 18. Then see, is it an even number? You can use 2, so 2 and 9. And then does 3 go into that number? Yes, 3 and 6. So therefore, that's all your factors for 18. 1, 2, 3, 6, 9, and 18, and so forth down through. And then the bottom is just giving you a fraction, asking you to find the greatest common factor. Let's see. Adding, subtracting, common denominators, going back through. I'm going to add those videos. They should explain this pretty well. Like I said, I didn't find any videos that kind of helped with that first section, but I did find a couple that are really good with the adding, subtracting, multiplying, and dividing. So I am going to post those videos for you to watch because they have great visual, people lining them up, putting the common denominators better than I can do right here, like I said, with the way I recorded. So I'm going to attach them so you can do that. But don't be afraid if the video is something you don't understand or something in the book that you're just like, I don't see it, to reach out to me and say, okay, I don't understand this. Can you help me walk me through it? So I think though those videos will help out. They're very short. They're actually like 8 or 9 minutes. They're much less windier than me. I've taken 27 minutes just doing this because I like to talk and I like people to listen. Just kidding. So again, I would go through, do as much of the work as you feel comfortable. I always say, if you need to do all the problems, do them all. If you only need to do maybe 5 or 6 and you got it, you got it. And again, I would definitely do the word problems, which are on page 70, and then the 71 and 72 are almost like a mini test for you. It's 20 questions. I always suggest at the end of the sections, do those skill checkup, do the whole 20, time yourself if you need to. Like I said, I don't think ever on tests we need to rush. But then check your own answers, see how you feel. And that's a good way to kind of understand which section you're struggling in or which one you're not. So again, that's my fraction thing. I'll be adding the test here soon. It's kind of tough just because I have to manually enter all the test questions and the answers. And as you've pointed out to me a couple times, I'm transferring from one to the other. I've made a couple little boo-boos, so but I think so far so good. So appreciate you guys. Hope everyone has a great resurrection week, and look forward to just getting through this. Just think we're almost 3 weeks through already. Kind of crazy. So be blessed, everyone. Have a great day.